Hello, everyone. Good morning, good afternoon, and good evening. Welcome to Couchbase Analytics keynote, and we are very excited that you could join us today. We hope you're all doing safe and staying healthy. I'm Idris Mochiwawa, Principal Product Manager at Couchbase, managing the analytics product portfolio. I've been in the industry for 25 plus years. I'm extremely happy to co-host this keynote with Michael Carey, Brent Professor of Information and Computer Sciences, and a distinguished professor of computer science at UC Irvine, where he leads the Asterisk DB project. Mike?
All right, tonight I'm Mike Carey. I'm super happy to be here with Idris, sort of co-presenting what we're doing in Couchbase Analytics. I've been doing databases for a while. I taught at the University of Wisconsin, worked at IBM Research, worked at VA Systems, and now sort of splitting my time between UC Irvine and Couchbase. And we're excited to share with you what's happening in analytics.
Great, thank you, Mike. So we're going to talk in our session today more about the industry trends on hybrid analytics. We're going to go through what is Couchbase Analytics and the services and the capabilities it provides. We'll discuss a few customer use cases, some of the new features which we recently announced as part of our release 6.6. And then Mike is going to walk through and cover the under the hood about the analytics service architecture, the partitioned parallelism, and what we're working next in our labs. So we're very excited. Let's start. All right, so before we get started, a little bit about the analytics trends. The business world is undergoing a massive change as industry after industry shifts to digital economy. Now, it's an economy powered by the internet and other 21st century technologies, the cloud, the mobile, social media, and big data. At the very heart of every digital economy, businesses are its web, mobile, and IoT. They are the primary way companies interact with customers today and how companies run more and more of their business. These interactions lead to creation of business data, and it's heartening to see over 65% of the enterprises use this data to drive the business strategies and make business decisions. In fact, in a more recent research study, 98% of the chief data officers indicated that they're continuing to investments in their data initiatives. Building and running web, mobile, and IoT applications has created a new set of technology requirements. The new enterprise technology architecture needs to be far more agile than ever before and requires an approach to real-time data management that can accommodate at unprecedented levels of scale. It is encouraging to see over 35% of the enterprises using some form of hybrid operational analytics built within their transaction systems. As you can see, data is a foundation and a critical element that powers all applications, and analytics could not be achieved without this data. Conversely, there are also barriers to analytics adoption, and the biggest challenge is not the technology, but people and processes as well. It's extremely motivating to see increasingly that 69% of the enterprises successfully use data and the analytics initiatives very successfully. Let's start with a few modern analytics challenges. There is little doubt that enterprises of different shapes and sizes recognize the value of data as never before. They are taking strategic decisions to become more data-driven. Becoming more data-driven is easier said than done and involves not only the adoption of new technologies, but also new approaches to data management. Developers and customers face multiple modern data and analytics challenges when working with JSON data. With growing data volumes and variety, developers are faced with increased challenges in how to make the data available to the users faster to enable real-time analytics on the underlying operational data. Traditional data warehouse requires schema modifications when JSON data source changes. Examples like this result in users unable to quickly obtain insights into what's happening in their business in order to monitor and optimize it. Also, in a way that doesn't interfere with your operational systems workloads. Now, with more data, you need more computations. There's a more need for more ad hoc, complex querying, complex analytical requests with larger joins, aggregations. Developers would like to offload these data processing requests from underlying transaction data to analytical data processing engines that support parallel query processing with bulk data handling. Now, as the underlying data grows, there is a need to manage various data flows from one system to another, increasing the data pipes to manage the extract, load, or transform, or extract, transform, or load, ELT or ETL processing. Often today, this involves having to transform the data before the analytical tools can process it. And of course, this all leads to increased cost, more systems and processes to maintain, and further adds complexity to data platform and infrastructure. We'll talk a little bit more about how this is addressed by the analytics service, and we will learn how the new features in analytics service makes it even more powerful. Let's talk about a little bit about the traditional operational analytics processing. The traditional application architecture separated transactional, the OLTP applications, and the analytical systems. As you can see here, transactional applications generated data that was later moved to a data warehouse or a data mart or data lakes in the past decade. The transactional data was periodically loaded via ETL, where often long-running OLAP queries could be run without slowing the transactional database performance. Now, though the enterprise data warehouse remains a historical, deep, introspective, predictive modeling tier, this architecture created a wall between the operational systems, example, the ERP, core banking systems, travel reservation systems, which are designed for efficient transaction processing, and the analytical environment, the data warehouses, the data marts, and the data lakes, designed for efficient reporting and analytics. This wall led to separate systems and introduced delays in and limited in immediate relevance of decision-making processes, because they could be based on after-the-fact analysis only. So what we are seeing is now the trend in hybrid operational analytics processing. It's also called as HTAP, as Gartner says, hybrid transactional analytics processing, or as Forrester calls it, translytics. This architecture breaks the wall between transaction processing and analytics, enabling more informed and in-business real-time decision-making. Now, part of this architecture appeal is more than just an efficiency strategy of fewer systems to maintain. It also has the ability to do analytics on incoming operational transactions. Hence, it blends both operational transactions and analytics within a single system or a platform and eliminates ETL delays. This is what we are calling analytics at the speed of transaction. HTAP is emerging application architecture that breaks this wall between transaction processing and analytics. The research is showing that hybrid is steadily taking a bite of pure OLTP workloads, as we talked about breaking the wall, and is expected to continue to do well in the future based on the analytical trends which we are seeing. So what we did, we designed in Couchbase Analytics and its architecture. Hybrid analytics was at its core. Hybrid analytics, as we said, blends both operational and analytics within a single platform and eliminates the ETL delays. Some of the key benefits, what we developed in our core framework, is for real-time analytics. So within the scope of a single application or a domain, data does not have to move from one operational database to a data warehouse. Transactional data is readily available for analytics when created. And we're able to drill down from analytic aggregates, always points to fresh application data. Some of the key use cases we are seeing in our analytics architecture and the customers are about financial services, it's in fraud detection, trading analytics, insurance, like risk analysis, e-commerce, like personalized recommendations, identification of segments, ad optimizations, healthcare, and Internet of Things. Let's walk through a few use cases for some of our customers that we have. One of our customers is a food delivery business, and their requirement was to track real-time marketing campaigns. And essentially, they wanted to track average transaction size of every e-commerce order, the annual purchase frequency, and their loyalty to determine the customer lifetime value. Underlying the need, they wanted to perform data exploration on incoming operational data in near real time with agile data science modeling. So they wanted to enable data mining models, which are focused on consumer behaviors, propensity scoring, and enable flexible attribute creation. So by applying Couchbase Analytics, they were able to enable new customer attributes, which were applied to data science experiments. And they were able to reduce the time it was taking them weeks or months to hours and enable those consumer marketing responses in a much faster pace. The second one here is a financial institution based out of EMEA. Their use case was they wanted to do price computations and risk scoring on hundreds of thousands of documents coming overnight, and they wanted to perform complex analytical queries, computations, enriching with third-party data without moving the data from Couchbase platform. And they initially only had limited data for processing in their existing query and data nodes, and they moved to look into analytics service. By employing analytics service, they powered their regression calculations to 1 million plus prices to further improve the query performance by more than 100%. And it spanned over 100 gigs of worth of data. Again, there was no need for any ETL for the JSON data moved from the operations to another space. They were able to do analytics right there. Third use case is of a healthcare company. This is a company which identifies revenue integrity for their customers. For example, their clients are hospitals, clinics, etc. They wanted to scale their data architecture essentially because they were being asked questions by the underlying customers on what are in the business intelligence. Like they wanted incremental data refresh, especially in the last 6 to 8 months. This is very relevant in our current scenario in the pandemic, where the executives wanted to answer, show me the business revenue impact for any impacts on COVID-19 related incidents coming in and the impact on hospitals canceling surgeries or elective procedures. And they were able to identify underpaid or unidentified revenue. So the key here was scale, and analytics service helped take that architecture. They were able to create the data sets into various partitions and by various time dimensions and customer dimensions, and they were able to smoothly answer those PI-related questions for the customer. So let's talk a little bit about Couchbase Analytics Service. So what is Couchbase Analytics Service? As you've seen earlier, so we have applications, we have the Couchbase Data Platform, we have the data service, the analytics service, and on the right, we have the ecosystem, we have data warehouse, a data lake, etc. So the analytics service helps users analyze JSON data in near real time without the need to ETL your data into a separate system. Basically, it allows you to develop insight-driven applications easily and quickly. Moreover, it removes the need for ETL and the complexity of managing a separate system. The users do this by creating shadow copies of the data they would like to further analyze, and Mike is going to talk more about it. When shadow data sets is a subset of the bucket which gets created and are connected to the data service. So there are two focus areas we want to stress here is operational analytics and near real time. Operational analytics is a process to use data analysis and business intelligence to improve efficiency and streamline everyday operations in real time. And business users can then query the analytics data using Nickel for Analytics without slowing down the operational data or query. With this continuous data ingestion, using the database change protocol between operational nodes and analytical nodes, allows operational and analytical queries to run concurrently without impacting one another. So as you can see from this, once your data gets in here, the analytics service becomes an area where it becomes an enabler to your other parts of your data ecosystem. You can even do analytics right here, connect it to your favorite BI tool, or you can do data science modeling as well. So the top business value is it removes the complexity of managing a separate system. Analytics runs on data that is current without the complexity and delays of ETL, and enable exploring and analyzing rich JSON data using SQL-like language. And there is a simplicity of a single platform with the advantage of workload isolation without the need to set up a separate analytical system. As our CTO, Ravi said, Couchbase is focused on data first and schema next. And this is true to the heart and the framework of how we design the analytical framework and the analytical service. We strive to provide the analytical speed of transactions I mentioned earlier. It's based on our MPP architecture, which Mike is going to talk more in detail, so that we can enable those faster time to insights to enable businesses to make even faster decisions. Let's talk a little bit more about our innovative new analytics features we recently announced as part of release 6.6. The first one is remote links. One of our use cases here coming in was from our customers. Hey, they wanted to extend the analytics reach. They wanted to ingest data from multiple Couchbase clusters that enable more data to be consolidated. So today, prior to 6.6, they were only able to analyze data within one Couchbase cluster. So we unleashed that in 6.6, and the use cases here were to combine and correlate data from multiple locations. There were multiple applications. There were local clusters serving into that and collecting analytics, and we wanted to get a 360 view of all the applications from all the clusters. Moreover, they also wanted to lower the analytics total cost of ownership. The possibility of having independent analytics cluster can now reduce or eliminate the need for analytics nodes to be included in each of those individual clusters. And it also enables even faster time to insight because customers can now gain more insight immediately by performing correlations across different sets of data without requiring the data of interest to first be published within a data warehouse. So it's almost like getting all the things. It allows you to bring your Couchbase Analytics into one place. So how does it work? So essentially, taking the same examples, now we have the ability now for in Couchbase platform to have multiple clusters, as you can see here, and you can now consolidate the data into one analytics service. And it follows the same principle. It leverages the capabilities of the database change protocol, except now it's unleashed, and we extend the database change protocol to read across the various data service nodes. And with remote links, this is now enabling the lowers the cost of ownership and support more comprehensive data analysis and decision making. So some of the key benefits are holistic insights. You're getting more data in a singular place with remote links that allows users to gather more insights. Getting remote data ingestion that allows the data to be coming from a remote Couchbase cluster to an analytics cluster, which enables more data consolidation. And it's more real time. It's using, as we talked about, DCP, the database change protocol. It's happening in real time. And lastly, but not the least, but reduce cost. The cost effectiveness, it reduces the TCO with centralized data management and improved resource utilization. So the next feature is external data sets. So this was one of the sought after feature customers have been asking for, is they want the ability for Couchbase Analytics to query external data sets which are outside of Couchbase data platform, not just in the data services and not in the analytics service. So they wanted to query data residing in the data lake in Amazon S3. They wanted to enrich that Couchbase data with that external data and also enable real-time insights. So what do? We extended our Couchbase Analytics framework, our architecture, to now dynamically read and stream the data through from Amazon's S3 bucket, and which are spanned across multiple AWS regions dynamically, which are retrieved during query execution and combined with existing analytical data sets. So it leverages the power of parallelized workloads, which means you can configure and set access to S3 data, and Couchbase's massively parallel performance architecture for optimized workloads. It provides access to externally stored data residing in Amazon's S3, as we said earlier. Also, it provides the ability to dynamically retrieve, combine, and analyze with S3 and with existing analytics data sets. And these features, right now, it's supporting JSON, CSV, and TSV, with more being planned, and Mike's going to talk more about it. The reach of analytics service, real-time query capabilities has been extended even to assets in S3-based data lakes. And this is very, very powerful and unleashing and extending our reach to the data lakes as well. The benefits of external data set, we talked about, it enables data enrichment. So you can actually retrieve the data which is coming from S3, you can derive some information from there, you can combine that with your data with the existing data sets. It extends the reach. Now it's going beyond it, so you can even create more insights and more analytics. And also it's real time, it's dynamic, and you get the faster time to insights. So I want to talk a little bit about, before I hand it over to Mike, about what are the key requirements for an agile analytics platform. There's some pillars here we can talk about in the platform. The first thing is timely. What we mean by that is your operational data is readily available for analytics. And this is the whole concept behind the hybrid analytics, HTAP or HOAP or Translytics. When the data is created and it's available for analytics, is as current as possible. And that's the world we are living in as we talk about the shift towards the digital platform, a digital economy. It's very, very important right now for businesses to make timely decisions. It also has to be flexible. We all know schema changes underlying the databases and on the operational side, and they don't want to impact the analysis on the analytical side. So with our capability where there's no need to ETL your data, it's immediately available on the analytics service. It wants to provide analytics and a more flexible attributes to it. Also, at the same time, the analytics platform needs to be high performance, it needs to be speedy, So that when you're asking questions from the analytics, you're running queries quickly without impacting any operational performance. And so speed is the name of the game here as well, along with timely and flexible. And lastly, but not the least, scalability is a very important element in analytics platforms. So as you're designing your data and your queries, also needs to scale up with your data and it's to speed up with your queries. Scalable works with all the three other factors which we talked about as well, and it's extremely important as you go from one to another. So I would like to hand it over to Mike and to talk more about the Couchbase architecture and under the hood. So Mike, take it away. Thanks.
So basically, Idris has told you the story of kind of what Couchbase Analytics is and what kinds of business requirements it meets, and how it fits into the universe in terms of the new trend towards HTAP or HOPE. And what I want to do is sort of drill down into that and look more at like, how does it work and how does it fit into your architecture? So kind of two architectural thoughts. One is, let's zoom out and look at your whole architecture and understand where analytics fits into that. And then let's zoom in and talk about how analytics sort of meets that. And so I would say what distinguishes us is we are like HOPE for JSON, right? So we're making JSON hopeful. How do we do that? Basically, you've got sort of a sense of that from Idris. We're using current operational data coming from the data service, flowing into the analytics service. You're doing your analysis kind of on your data in the data model that you're used to thinking about your data if you're an application developer, not waiting for ETL and not having to kind of move to a whole different schema. Workload isolation, and we'll talk more about how that works, and performance on complex queries, and we'll talk more about how that works too. So I'm going to sort of take it from this high-level view of Couchbase Analytics to how does this fit into the even higher level view, and then if we double click on this, like what do we see? Okay, so this is probably something like what your ecosystem looks like for analytics kind of in the whole in your enterprise, right? So you've got applications, a bunch of different applications here. We've got a shopping application, online shopping. Someone chose Couchbase for that, wisely, of course. We had maybe a customer call center, another Couchbase-based application. Doing something with social media, and unfortunately sort of maybe chose a competitor's NoSQL database. And then maybe we're doing something with obviously with a relational database for some sort of businessy, headquartersy things. So there's these different applications, each of which is running on a different operational database. And then typically in an enterprise, what you'll see is that sort of the activities from those operational databases are ETL'd into a data warehouse, perhaps in older days. Possibly raw data deposits are being made in a data lake, and then data is being, data products are being computed and ETL'd into a warehouse. But essentially, your operational data is being transformed in some way into kind of your central data. And then BI tools, Viz tools, data science tools, and other things work off of those. And let me just move our little picture out of the way so that I can continue to point at the things I need to point at. All right, so on the right-hand side, we have analysts, right? So these are kind of on the far shore of the data lake or on the other side of the data warehouse doing their analyses and to just kind of get across the idea of the delays. We see the hourglass, basically, this information is being generated, but there's, periodic ETL into the middle. And then on the other side of the lake or the other side of the warehouse building, the analysts are able to do their thing. And so how does Couchbase Analytics kind of change that picture? So what it allows you to do essentially is to start moving your analysts from the right to the left. So we can take the first analyst at the top who's doing some analysis of the shopping application. And with Couchbase Analytics, they can actually now use our Hope for JSON story and do that analysis of what's happening like right now on their e-commerce site directly on a shadow copy. And we'll talk more about that in a few slides of their current data. So they're basically operating on current data, doing the analysis like quickly in very little time, near real time, as opposed to being sort of on the far side of the data lake, waiting for the data to flow all the way across to where they can see it. And that story repeats, right? So if we have another application like our customer call center, we can move the analyst who wanted to look at the results of that data also over here, and they can be seeing what's going on right now in that customer call center. So one by one, we're able to take analysts who used to have to wait maybe till tomorrow to analyze their data. And if they had new needs, they had to wait for new ETLs and things to be developed, and then they could start to do their analysis. Those analysts are now able to do their jobs on current data. And so they're able to get their insights faster and in a more relevant way because they're getting it right on the data kind of as it's happening. But we've still got a bunch of analysts over here. So some of them may have wished that they could like look at what's going on the commerce site and look at what's going on in the customer call center, right? So maybe some new product or some website changes get made on the commerce site, and people are abandoning their shopping carts, and the things are heating up at the customer call center. What's going on? Well, the analyst who might have wanted to look at that with the addition of remote links can now have a consolidated cluster, which is getting kind of data flowing in real time from these two applications, and they can do that analysis rather than on the far side of the data lake right here, like right now on that data, and do those cross correlations. And then maybe there's another analyst who kind of wanted to do that, but needed some information from their, sort of from the cloud, from S3 storage. And so now with the addition of data links, they're able to do that too. And so the thing to see is that we've got these analysts, all of whom used to be kind of sitting on the far side waiting for their data products. More and more of whom can now basically see the data as it's changing, do their analysis, and take the appropriate actions, and deal with whatever's causing things across applications. So that's kind of how this fits into the architecture. So again, you've got your applications, your operational databases, and now you can start to do analysis in a, let's call it a hopeful way. And you can do that on your JSON data. You can think in terms of your application data model. And then still, you'll have your data warehouse, you'll have your data lake, you'll be certainly making deposits because you're going to want to be sort of dealing with all of your data for some of your analysis if you want to do customer 360. And we're not saying that you don't need that anymore. These analysts still have a job to do and they'll still do that. But a number of these analysts can now be sort of more agile, if you will, and analyze the data that's as it's happening. All right, so fits into the world, but why a different service, right? So we have the query service in Couchbase, and you may be familiar with that and happily using that, using NoSQL for query. And you may be wondering, like, why is the analytics service something separate? What's that about? And so it's about a couple things. So one thing is it's about performance isolation, right? So here we've got users who are doing, buying things or calling into the call center or the sort of the interactive equivalent of that. And these users are, wanting to be responded to quickly. Analytics can weigh down a system, and we don't want the analysts who have important business questions to ask and hopefully new features to roll out on the website as a result of that. We don't want what they're doing to be interfering with the data activity, right? And so that separation, that physical separation, that isolation, performance isolation is one important thing. And so in the architecture, basically we have the data service, and we're, that's horizontally scalable to handle its user base. And we also have the analytics service, which is horizontally scalable to handle its query base. And we'll talk about those scalability features as we go the next few slides. So that tells you kind of you want to have two things, but like, why not two query services? Why a query service and an analytics service? So the reason is that to do these things correctly, to do them right, and to be really performant, and to make them each sort of the best that they can be, the query service needs to be designed in such a way that it can handle simple, small requests very quickly. I've got a user, they come to the website, they enter their email address, I want to find their record, I want to find the associated orders, that all has to happen very quickly. And so the query service, Query for NoSQL, is designed to, NoSQL for Query is designed to handle small requests, lots and lots of small requests, all running simultaneously, provide low latency operations, to be able to scale the operation. So if the web, if the company is taking off and more users are joining, we want to be able to scale that data service out and respond to that by handling more concurrent requests. And to do these requests quickly, what you see in OLTP kinds of systems is they tend to have a fairly centralized point-to-point-ish execution architecture, so that it's like, look this up, look that up, answered. And so they have a more centralized approach to the way that the query processing works under the hood. For an analytics service, life is different, right? We have some larger users with bigger questions, maybe ad hoc queries, complicated aggregations, joins, window queries, those kinds of things. And so these are complex requests. What we want is not so much to have a gazillion of these happening in parallel, but to have a set of them running and able to answer these kinds of complex queries effectively. So each query, we want to provide low response time for that query and be able to run a set of those queries. But low response time for an individual query is very important because these are complex queries that touch a bunch of data. We want to be able to speed up queries by scaling out the analytics side. So for example, if your query is running a little bit too slowly and you want to get that time down, you can add analytics nodes and that query will now run more quickly. Or conversely, if you're getting more and more data, you don't want to analyze 3 months of data, you need to get insights from 6 months of data, you can scale up the analytics side and get the same answers on more data in the same time. And so the secret to that is being able to execute queries in parallel, right? So the query service has a more centralized internal architecture, and the analytics service, which I'm going to talk more about, double click on, it has a parallel architecture under the hood, which is similar to what you find in state-of-the-art data warehouse systems for relational, for flat data. Okay, so how does this two-service architecture work? So I alluded to some of it already. So we've got a set of nodes running the data service. We have a set of nodes that are running the analytics service. And as Idris mentioned, inside Couchbase Server, there's this protocol called the data change protocol, or DCP for short. And data is continuously being ingested into the analytics nodes from the data service nodes. And again, you can scale these independently with multidimensional scaling from, sort of one of the sort of trademark features of Couchbase for its services. Okay. Add to that the query processing that you need to get your insights fast from a given query. So sort of think about your data as sort of being a big pile of data. That big pile of data is actually scattered across the analytics, sharded across the analytics service nodes. So here we see sort of 3 nodes. Each one of those nodes has a partition of that data and has a set of cores that are going to be operating on that. And so in the middle, we've got a parallel architecture for running queries sort of in parallel in ways that I'll talk about in the next few slides. And then together, those things then allow you to get sort of rapid insights, right? You're getting data that's current, you're getting your queries processed very quickly, and that minimizes your time to insight. So that's how we sort of deliver hope for analytics. Okay, so let me just tell you a little bit on what's going on under the hood inside the analytics service, so you can kind of appreciate why it's a technology that may very well be able to help solve your problems, right? So inside the system, analytics stores, indexes, processes queries against the data. And so the storage is partitioned, right? It's sharded across the multiple analytics nodes. So basically all of your data sets basically are sharded across those nodes. So this data set would be split across these 3 nodes. And then all of the indexes that are indexing your data are also split across those nodes. And so, this is sort of a picture of your data sets. Your data is hashed on its primary key onto the partitions of your analytics cluster, onto each of your nodes, or actually each of the storage devices on each of your nodes. And then they have local secondary indexes that are the part of the index that's relevant to the data. So the index for a particular JSON object is sitting right next to that JSON object. It's in that same partition, which is a different kind of architecture than what you see in the query service and its indexing service. Again, because here we're after parallelism as opposed to being after quick point-to-point query processing. So that's just a little bit of a vision as what's going on under the hood. Like if we were to double click again, I could tell you about log structured merge trees and other interesting technologies that are inside. But the thing to take away is your data sets are partitioned across your nodes. They're locally indexed, and we can do things with that we'll be talking about in a second. What is that? Partitioned parallelism. So this is essentially the secret sauce for sort of the MPP. It's sort of a divide and conquer approach to answering your queries. So what does that mean? Well, let me talk about each of the kinds of things you might want to do. So one of the things you may want to do is like find all the objects that satisfy a certain criteria, do a selection. And maybe you need to scan all of your data to do that, or maybe you can use a secondary index to sort of subset the data. But in either case, what analytics execution engine does for you is it does that in parallel. So it basically takes that request and it splits it across those nodes, and each of those nodes does its piece of that in parallel. So things as simple as selections are applied in parallel, and they're easy to do in parallel. They're often called embarrassingly parallel kind of in the literature. You may want to do grouped aggregation, right? So it may be that you want to do some sort of groupy aggregated query. I'm not going to drill into this too much on this slide because I'll give you an example on the next slide. But we do this in parallel as well. So if you're trying to sort of answer a grouped aggregation query, we'll do a local piece of that. We'll repartition the data and we'll do a global piece of that. And you'll see that on the next slide. What else might you want to do? Well, you may want to do sorting. You may want to order your data in some way. And so analytics says, okay, fine, I'll do that for you in parallel, right? So your data is scattered across the cluster. Each node in the cluster will locally sort what it has, and then those sorts will be merged to compute the final result. Or for extra credit, there's an even more advanced parallel sort that's available where the data is sort of sampled and repartitioned, and then everyone sort of samples their, sorts their range of that. Again, the key here is that we're taking an operation that you may want to do on your data, and it's happening in parallel on all the nodes for that one query. Okay, joins, same story. So if you want to do a join, your data is, one of your data sets is on all of your nodes. The other of your data sets are on all of your nodes. We repartition that data on join keys to bring together the data that might join, and we do parallel local joins. So joins are executed in parallel. And why stop there? Windowing queries are another important part of analyses. So to get parallelism there, we will repartition your data on the partition keys from your window clause, and we'll do parallel local windowing to answer your query, right? So it's parallel selection, parallel grouped aggregation, parallel sorting, parallel joins, parallel windowing. You want fast answers to your queries, and parallelism is our answer, right? So did I mention that each query executes in parallel, right? That's the theme. So again, partition parallelism is what's happening under the hood of analytics, and it's how we can deliver you fast answers to what's happening on your current data. So let me just give you one example of that to really get across that idea. So, one of the sample data sets that you get from Couchbase when you get Couchbase Server is the all-important beer sample, my personal favorite. And so here's like an artist's conception of that data set. So here we have information in the beers subset, let's say, of the beers bucket, the beer sample bucket. That data is scattered across your cluster. So here's your data in analytics. You've got information about beers on this node, information about beers on this node, and information about still more beers on this node. And notice that each node has information about different brewery IDs. So your data it's partitioned on the primary key of your beers, not on brewery ID. So we've got data scattered across the cluster. And we need an important piece of information, which is, okay, for each brewery, how many beers do they have, right? This is clearly an important question. So this is an example of the query that you might ask. Let me count as num beers and group by the brewery ID and get out the brewery ID from beers. So for each brewery, how many beers do they have? And again, note down here, the way the data is stored is that information needed to compute the query's answer gets scattered across the cluster. So what happens with massively parallel processing, AKA partition parallelism? So there's 3 steps. So what we're going to do is we're going to compute local aggregate. The analytics engine will locally aggregate the data. It'll repartition the data by brewery ID, and then it'll again aggregate. So let's look at that and understand like how that parallelism works, just again to give you kind of an appreciation for what happens under the hood in analytics. So the first step, local aggregation, basically has each of the nodes, and they'll do this in parallel, will compute for each brewery how many beers they see for that brewery on that node, right? So on this node, we see that brewery ID 3 has 2 beers. Over here on the right, we see that brewery ID 3 has 1 beer on this node. So each of these nodes is computed for each brewery ID, the partial aggregate, the number of beers for that brewery ID locally, done with local aggregation. The next step is now to reshuffle the data so that we can finish the job also in parallel. So the data gets reshuffled and it's basically repartitioned by brewery ID. So what we see in this little example is now brewery ID 2, all the data that was computed from these different nodes is now sitting here, has been moved to that node. And so this node knows everything about brewery ID 2. This node's got all the info for 3. This node's got all the info for 1. And now we can compute the final answer to the query again in parallel. Right, so each of those nodes can now say, okay, let me add up the numbers of beers. And so this node now knows that brewery ID 2 has 3 beers. This node knows that brewery ID 3 has 3 beers. And this node knows that brewery ID 1 has 3 beers. Clearly, we don't have enough beer, but we do have the answer to our query. Okay, so that's how, just one example. And similar things I could show you for joins, I could show you for windowing and things like that. But I think this will kind of give you a sense of what it means to do aggregation, grouped aggregation in parallel. All right, so let me wrap up. That's probably enough technical detail by just saying a little bit about what's under the hood of remote links and what's under the hood of external data sets. So when we sort of last left our IT architecture, we'd moved these analysts over here, right? And we were able to do that because we have sort of the shadow copies right here in this consolidated cluster, which can also reach into sort of dip its toes in your data lake. And all these analysts can do their job. Are we doing something in parallel for this? And the answer is yes, we are. So basically the DCP streams from your various Couchbase applications, and notice that the Centerprise sort of saw the light and is now using Couchbase for all three of these things. DCP streams are flowing from the operational databases in each of these clusters in parallel into your consolidated cluster. And so DCP is still the technology, as I just also mentioned, that underlies this. It's now that it's possible to have multiple of your data services feeding into one consolidated analytics cluster. Also, again, parallelism. What do we do about that data lake access? And the answer is we apply partition parallelism there too. So if your data lake, sort of the files that you need to access, the underlying data are lots of little files, what will happen is we will launch a partitioned parallel sort of activity to go and read those files in parallel, so that when we're doing query processing and mixing your data in Couchbase with your data from the data lake, that again, we're applying that parallelism in order to get those queries to run quickly and to basically deliver your results to you effectively and quickly. All right, and so again, the thing to notice is we've got this time improvement, right? So we've gone from slow to like right now in doing that data analysis. Okay, and as a result, we've got, making good progress towards customer 360. So right now we've got, sort of customer 270 here, sitting here on the Couchbase side of the world, not on the far side of the data lake. Okay, so that's kind of a sense. Hopefully I've given you some sense of how it is that analytics works, how it fits into your architecture, and how it's able to deliver sort of timely results. So what's next? Okay, what is it that we're going to be doing? So how can it possibly get better than this, right? So we're doing a number of things. So one thing is kind of a company-wide focus in the next release or forthcoming release of collections, right? So buckets have been the thing in Couchbase Server for a while. Analytics has had a notion of data sets, which are more collection-like, and there will be collections across the Couchbase platform to make for a much finer-grained, much more usable user experience for managing the sets of data that you need for your applications. And so analytics is participating in that, and you'll be seeing that coming out. We're also working on sort of more advanced aggregation features. And so if you have insights you want to gain, you probably like things from SQL like cube and rollup and grouping sets. And so those will be coming to Nickel for Analytics in a future release. Also, external data sets seem like a great idea, right? So you've got S3 data sets today, and those can be, as Idris mentioned, either on-prem or in the cloud. So it can be, true AWS S3 data sets, or it could be, sort of S3 interface in a storage appliance in your data center. But what about sort of other external data sets? And so some of the things on the roadmap, sort of again for future releases, are Azure. So Azure storage is one thing that would be obviously of interest to customers. And then also other file formats, right? So we have CSV, TSV, and JSON today. Parquet is very popular in data lakes, so we'd like to have support for that. What else is coming? So the other thing is we're starting to look at machine learning and how does that interact with analytics, sort of really advanced analytics. And so we're taking some steps along those lines. Again, things coming in a future release. One is user-defined functions that you can write in Nickel for Analytics so that you can actually sort of create nice functions. So that's the user-defined functions part of this. And then we're interested also in user-defined functions to support machine learning. And so that translates into being able to support things like Python user-defined functions, functions that may have been created by one of the machine learning libraries, scikit-learn or PyTorch or one of those libraries, so that you could actually create those as user-defined functions and execute queries where that call of that function is one of the criteria in your query. Sort of find me all the, sort of all the customer call records where the customer seems, let's say, aggravated, and that aggravation model has been trained in scikit-learn. And so, collections, advanced aggregation, enhanced external data sets, machine learning. What else? Also, we're looking at some under the hood enhancements and some of the storage related technology like support for array indexes in the future in Couchbase Analytics. So again, a future release will have that so that we can process even more queries using indexes quickly. And then lots more. Okay, so sort of more integrations, analytics on Couchbase Cloud is coming as one of the very important things down the road. And so that's just a little bit of a sense. I can't tell you, which release will have which. They'd kill me if I told you, but that gives you some sense of kind of what's happening. Okay. So at this point, I think I'll turn it back over to Idris and let him wrap it up for us.
Yes, thank you, Mike. This was really, really informational, and I hope everyone who's attending the session, thanks for taking the time and attending the session. Please attend the other analytics sessions as listed here. We have more deep dive use case demonstrations and demo on how analytics service is using remote links, external data sets, how it's connecting with our the last mile, connecting to visualization tools as well. And also, I think the big data analysis with SQL with Dimitri and Till. It's very, very hands-on. A lot of cool and technical things in there. Thank you once again. Hope you all enjoyed this session with us, and please feel free to send us any Q&As in the session, and we'll be more than happy to answer. Have a great connect and enjoy the conference. Thank you.